So we use the instructor library to wrap the OpenAPI client. So we define a client, and then we let the instructor library basically make some adjustments to the OpenAI client. And then once we have this, we can use it to prompt the model, right? So let's create a main over here. Okay. So the input parameter is basically like a string, and we comment this one out for now. Okay. And then we can collect the response, and then we can print it. And as we saw before, the response is a Pydantic model. So for easy viewing, we can again use the model.json and then format it with 4 spaces. So if I run this, okay, so we can see that the response came back with, which is structured exactly as we specified over here. And any question on this?
Oh. So far, so good.
Far so good? Okay.
Yeah.
Cool. So we can probably do like a couple of more examples over here. So, and then print them. Let's go over there. Okay. Forward this. Okay, so the default formatting is basically like a Python class, unless we specify the additional method to see the JSON equivalent. Okay. So that's it for that. Okay, so one last feature that we can implement through the bot has to do with the ability to run background tasks. And so the scenario for this, I wanted to implement the full scenario that I had in mind, but I shrunk it down to something more simple, given the time constraint that we have for the meeting. But the real scenario that I had in mind was pretty much, if you can imagine, like a participant of a given channel on Discord, let's say, ask a question, right? And maybe the people on the server may not have the answer like ready to go, right? We could implement an agent using based on LLMs, right? So the bot will basically delegate the task to an agent, meaning that it may not respond right away. It could instead just acknowledge that it's aware of the request and that it may answer later on, right? And then during this time, the bot takes care of persisting the user that made the request, as well as the channel details. And then when the request is passed on to an agent that runs somewhere in the background. The agent can take its time to do the processing. And then whenever it's done, right, whenever it's done, it has, let's say it persists the result of that request somewhere, maybe in a database. And then from time to time, through the background task of that runs inside, that runs as part of the bot will every now and then check on the agent to see if the job was completed. And then if it is completed, it can ask the agents to provide the result of the task. And then with the username, as well as the channel information, the bot can then respond on the channel and at the same time notify the user that made that request, through like the mentions. And so that's what I'm gonna show you now. So if I switch back to the bots here, let me remove my comments. Okay. So so in order to create the background task, we have access to the tasks module, through the discord.ext. We have access to the task annotation through the discord.ext module, right? And let's see. And then since this one has to keep running, it has an idea of a loop because it's a recurring thing. And then we can specify how often we want it to run, right? So maybe we can decrease this to, let's say, like every minute. Okay. And then the function name doesn't really matter. It can be any function name. And then this line is not necessary, but I'm just using it to add some additional delay before some small delay before the task executes. And okay, and now I'm retrieving all of the channels, that are visible by the bot. And then my goal here is to only run this task as part of a specific channel, right? And not only as part of a specific channel, but also target some specific users in my case, right? Basically, I'm looking for the goals that we have in the channel, right? So getting a hold of all of the channels, I make sure that I'm in the right channel, like the bot experiments in this case. And then I can send a message, and then I collect all of the members of that channel, right? And then and just like before, just like we saw above, if the user matches the bot, like we don't want to do anything. So in this case, we don't want to target the bot itself, right? We just want to target other people. And we saw that the bot doesn't like to be called Gao, so it doesn't consider itself to be one of them. And to finally target the users, those Gao users, like they have some specificities in the name, right? One is an African, another one has something to do with dogs, and then the other two have LLE and Brew, right? So we sleep for a few seconds, and then we can pick a model, right? And then once we pick a model, we can make a query. Okay. So let me rephrase this part. In this specific part, what's happening is that once the goals have been located, the bot wants to address them like with a message. And to help put together a good message for them, it's going to, behind the scenes, employ the instructor library together with Pydantic in order to formulate the message and then send it to them. Right? So the message in question is basically a joke. And then once the joke has been collected, it just sends it out to the channel. Any question on this code? Okay. So let's get into more details. Okay. So you can see that the function that I'm invoking is this one called Genisync client to get a client based on the choice of model. And then once I have the LLM client in hand, I can use it to generate the joke using these other methods. But first, let's look at the get client. So by default, we're using GPT-4 only, like the new one that came out this week. But other choices are Claude and Llama 3, like I mentioned. And then as we saw before, we use the instructor library to wrap the actual client for the specific model. So in this case, we have Anthropic, and the same thing is done by for the OpenAI, and then also Grok. So I don't know if you guys are familiar with Grok. Let's see, Grok Cloud. Grok Cloud. Yeah, so you can look it up. Grok basically came up with some new GPU architecture that make inference very, very fast, right? So a typical model that runs like at a certain speed, will run much, much faster on the GPUs provided by Grok, right? So you can look it up. Let's see if there are a better link. And that's a better link over here. Okay. Right. So this is how the client is picked. And you can see the imports are from the specific libraries, whether it's Grok, OpenAI, or Anthropic. And so the second method to generate the jokes is this one. So it's actually very simple. Let me see. Where's the Explore? So it's similar to similar to what we saw before. So the structure of the call is basically like it needs to have a model, and then it needs to have the Pydantic, if you want, contract to structure the shape of the response from the model. And then we just prompt it as a user, right? So the same thing is being done here, except that I have a little bit more details for what the model is supposed to accomplish. Basically, it takes in the goal name, right? And then it's gonna use these specifications to come up with a good joke, right? And then the response will basically have this shape, right? So again, this is the Pydantic syntax. the response is a string, and then I have some metadata to describe the, to describe that field. So it helps. It's some for the text of the description provides more guidance to the model in the way that it's gonna shape the joke, and then the joke can be made in any of those languages that are specified, right? So from this GAU joke model, like a JSON spec will be provided to the large language model, and then finally this will run, and then it will provide us the joke. So let's run it once. Okay, so we can see it happening. So there's a small delay. Let's see. I think I added a delay for like 8 seconds. Okay, so it got the first one. And then there's a second one. Okay. So any questions so far?
I guess why are these people the GAUs and only?
Well, who knows?
So GAU is technically a fool. It's actually a fool. It's a fool. So that people know.
Okay. So any other questions or reactions like on this one? No? Okay, so let's proceed. So we can let this one run in the background, right? So now we're going to look at some DevOps. Let's say we want to deploy, we want to package this bot and deploy it on the internet, because if I were to shut down my machine, the bot will also shut down, right? But we want the bot to actually keep running. So to do that, we're going to use a combination of Docker as well as a virtual machine in the cloud. So let me go ahead and provision a machine real quick. I'm using AWS Lightsail, and share the link here. Okay, so I want to create an instance. I just need the operating system, and I'm gonna pick this one, Ubuntu 2204. Right, I'll just pick a cheap one, $5 a month, and let's call this one enhance.vm. Okay, so create. Okay, so while this is being provisioned, we can look at what the infrastructure looks like. So, okay. So I have a helper bash script over here. So it's very simple. If we scroll down, basically this is like a small illustration of what's happening. We have a Docker file in which we're gonna specify what's required for the bot to run in terms of environment, Python version, libraries, and so on and so on. Right, so that will be our blueprint, and then we'll package it, and also it's gonna be like similar to a prefab house, and then we're gonna make it available to the virtual machine. And then on the virtual machine, we're gonna run it, right? So for that to happen, we need to have two Docker engines available to us. One on the local machine so that we can create the Docker image, and then the second one on the target virtual machine so that it can run the said image, right? But how do we move? How are we going to? How can we move the Docker image that was built locally and make it available to the virtual machine in the cloud? So to make it accessible to the VM in the cloud, we're gonna make use of a Docker repository, right? So I know, like most examples you might see online, will use Docker Hub or the equivalent in AWS or Google Cloud and so on, right? But to make it easy, I'm gonna use one that's called ttl.sh. So this one is a free one. It's not recommended for production, by the way, but it's just a free one, a freely accessible one that exists where we can publish some images, and then, like the name indicates, the TTL, like time to live. These images that are published there will expire, at some point and be deleted, right? So for quick proof of concepts like we are doing now, it's perfect, right? And like I mentioned earlier, my local machine is a Mac. I'm running I think M1 or like ARM architecture, and the target machine on AWS, it's a Linux machine, and it's using a different CPU, most likely this one, AMD 64, right? So regular like architecture for VMs, right? So it means that when I'm building the Docker image locally, I need to make sure to target this platform, right? So any question on that? Okay. So let's keep going. So the syntax is here. To build a container image specific for a platform, right? I just have to add the -- platform and specify which platform it is. And then I have to tag the image. And then I also have to specify the actual Docker file, right? So we can see what the Docker file looks like. Okay, it's very simple. So basically, target Python 3.12.3, which is the same as the one I have locally. Okay, same thing. And I want to run it on Alpine Linux. So the reason I'm picking Alpine is because it's very small. It's an image that has the bare minimums, right? So it means that even those things that I'm adding on line 5 are not there by default. But since Python requires it, I'm just adding just what Python needs in order to install the dependencies and run, right? The working directory is basically this one, this one where the code lives, right? And then to start it, I'm just invoking Python and then the Python script, just like I'm doing in the IDE over here. Any question on that? Okay, no questions. Okay, so let's see. Let me check to see the images here. Oh, I built it earlier, so let me Let me remove this one. Just clean up and do it again. Okay. So this is the same script that I showed you earlier. The script basically has some options. The script has some options. So it has the Dockerize. We're gonna use this option to build the image, but it has other options as well. And then it prints when none of the options are selected. It just prints to show the user what's available. Okay, so that's what you're seeing here, right? But we're gonna use this one. So you can notice something here. I mentioned that the ttl.sh is the Docker repository we're gonna use. Actually, let me share the link with you. Right. So the convention is that when we create images, they have to use the ttl.sh namespace, and then the tag is actually the time that the image should remain available on TTL, right? So you can see, like in this example, is 2 hours. I'm pretty sure there's a maximum time limit. I haven't looked it up, but for our purpose, 1 hour is good enough. So I can run this. Okay, so like I was saying, it's building the image for Linux AMD 64. Right. And it's using the Docker file that I showed earlier. Okay, so the image is built. So if I do, let's see. So we can see that it has the tag for one each, which is for 1 hour. And then it's been built 12 seconds ago, and it has this size. And there was a recommended link in here. So clicking that link shows up some details about the image. Right? So we can recognize the Python and the Alpine and so on and so on. Right? Okay, so now that we have the image, we can publish it to TTL. But before we publish it, actually, let's see the progress of the machine here. Okay, so the machine has been built. And actually, let me clone this one. Okay, I'll move one over here. Like in the other window I moved, that's the window that I'm gonna use to basically set the environment variables. I just don't want to leak them. So clicking this link, gives us shell access to basically to the VM, right? And let's see here. 1 second. Okay. So let's put this one on the side for now. There's one thing that we need to do. like I mentioned, we saw that we are using Docker on the local machine. So this is the first Docker engine that I mentioned. We need to have a Docker engine running on the target VM. So in order to do that, we need to install it. And since we're using Ubuntu and Ubuntu VM, and we can run these apt commands in order to set up Docker. So let me copy, actually, let me click the link here. So I'll copy this. Then I'm just gonna paste these comments. Okay, so what was the, oh, she didn't pick up the login thing. So yeah, to run, execute the rest. So let me copy the next command. So we just did, so we just did this one, the update. So the next command is this one. So the next command is this one. Right, and I have to confirm. Okay. Then next, we have to install, we have to download the key from Docker. Basically, it's going to help us validate the installation of Docker. Make sure that when we download Docker, we actually have we have an actual image that comes from Docker itself, an authentic image. Right? And then we have to run updates again. Okay. Now we can go ahead and install Docker. We'll confirm. Okay. So now we can add Docker to the user group. And then we can check the status of Docker. Okay, so Docker is up and running. Right. Oh, okay. I guess I have to run it with sudo. There's some additional steps that I need to do in order to run Docker without having to run it as root. But we're not gonna get into that right now. I'll just use sudo. Right. So if I switch back to this, then we can go ahead and publish the image. So I can show you again. So all it does is to call Docker push, and then the tag of the name and tag, the namespace, the image name, and the tag, right? So again, so the namespace, the image name, and then the tag. So that's the one in here. Okay, it's almost done. Okay, it's done. So at this point, we have the image available on ttl.sh. So let's see. So we have one more step, which is to install the tool I was showing earlier, if you remember, like this one, the dear environment. This one helps us, like I mentioned, it helps us manage the environment variables, right? So we saw how that we are using several services that are only accessible with some keys, right? So Anthropic, Discord, Grok, and OpenAI, right? And by convention, the file that contains the actual values is this one. So we can create that file on the server. Right. So I create the file, but let me populate it on the side. So I have to copy the contents of the file real quick. Okay. Give me a second. I'm just gonna populate that file we just created. Okay, I've just done it. So now we can install the same tool, that same tool on the virtual machine. So the command is very simple. It's just sudo apt install their environment. Okay, and now we can configure it for the shell. So by default, it's using bash. So we're gonna configure the tool for bash. So we just have to evaluate this command. And okay, so you can see that it detected the .envrc file, but it's blocked by default. So we have to allow it. Okay, so you can see how that it picked up all of the environment variable. Okay, so now actually, hold on. Since we're gonna run the bot on the VM, we have to stop the one that's currently running. And the reason for that is that Discord only allows for a single connection, per API key. So since the API key will be used from the VM. It cannot be shared at the same time by a bot, by another bot running locally, right? So that's why I had to shut down the other one. And to run it, we just have to run the same. Let me grab the actual name. Okay, so this is the one we pushed, and we can run it like this. Oh, actually, hold on. I have to grab the full command. Wait. So we have to run Docker, and then we have to pass. Basically, we have to inject these variables inside the container. Sorry, I licked my keys. I didn't want to do that. Let me grab the name again. So it's this one. So the command should have been like this, right? But we have to run through sudo, and then we're just missing the environment variables. So if I run the allow again to have the names. Okay. Just copy and paste. So this is the name of the variable, and then we pass we refer to the actual value like this. Then same thing for Discord. And so for each one of the variables, we have to do -e, -e. Okay. -e. Okay. And then the last one. Okay. So if I run this, let's see, is in Docker. Wait, I think I have the run in the wrong place. Okay, so you can see that it's downloading the image locally before it can run it. Okay, let me try to put this one on the side so we can see it coming online. Let me see if I can ping it. Okay, so you see, I can ping it. It's gonna start cracking jokes now. I think it's the small delay for a few seconds. Okay. So we can see the jokes happening. Yep, that's pretty much it. Maybe one last thing. Let me stop this. In reality, it's not enough to just do a Docker run. We have to run it in the background because if I'm not running it in the background and close the window, the bot is gonna shut down. So the flag to Docker to mention that we want to run it in the background is -d, right? So this time the process is just gonna return to the shell. Okay, hold on. I have it in the wrong place again. So let's see. So -d. Okay, so you see it returned right away, right? And if I do sudo docker, yes. Okay, so we can see that it's running. It has this ID. And we can even tell the logs. I forgot to do. We have to put sudo. Okay, so we can see the same logs as earlier. Then we can see that the bot is up and running. Yep, that's pretty much it. Any questions?
No, that was very informative.
Yeah. Yeah, like I said, like I had some ideas to like really build something more like more involved, but I thought that it may not fit into the length of the meeting. So if you guys are interested, you can let me know, and then I could do like a part that's way more involved, that has more interesting features than just like cracking jokes. Yeah.
Yeah. I don't see. The only thing is the one. I think you already shared the gist, right, for the code. I think you've shared it at the top. There were folks asking. I'll drop it again.
Yeah, let me share it again. So let me see. I can close this one now. It's gonna keep running. Where is the chat window? 1 second. Just okay, there you go.
Yeah, I don't see any other questions. The only thing maybe after the kind of like as a parking lot, some that Brunel had something he wanted to share, but that's when we're done with this, Brunel, Ben, when you're done, we can give the mic to Samda, Brunel.
Yeah, you can bring it up now. That's pretty much what I wanted to show you.
Okay.
So, yeah.
For the others, that is the end of the session. If you want to stay, you can, but this is basically the end of the session here. And for those, again, if it's your first time, thank you for coming, and 2 weeks again. So Samda, you have the mic, sir.
Yeah, go ahead.
Okay. No, thanks everybody. So thanks Ben again for your presentation. So we went through a lot of I'm trying to put everything together. I've learned a lot throughout the year. So at this project, I'm trying to see how I can integrate the AI, right, based on everything I've learned from you guys. So I'll screen, if you don't mind. So,
Ben, while Samda is pulling this up, do you mind stopping the bot? Like it's sending a lot of messages, so it's like making that little Discord noise.
Is that the true reason, or you don't like the jokes?
Yeah, the jokes are it's not leaving me alone.
The bot called me a gal.
Okay.
Can you see my screen?
Yeah.
Yes. Basically, think about it like a marketplace, right? So you have let's take you have a plaza right here and a mall where you have restaurant, events, car repairs and stuff. So we gather all the offers from this plaza, and plaza 1, plaza 2, a different location. So everything is already inside the database. This is something, if we want to kind of learn how to do it, we can ask someone to kind of rebuild it. Maybe that's going to be also a good exercise. But basically, the idea is to gather all the offers from the different locations like that, to put them inside. You have the backend. So the database, the S3 bucket, where you have different files like PDF, images, and videos. So what I would like the AI to be able to do is to pull all the offers and data from the backend and be able to show it to a user in a very simplistic way. So the user has to just click on probably eat or shop. Let's suppose if I click on eat, it's going to kind of look at where I am and suggest things from this restaurant. If I want to shop, it's going to kind of pull different things like that. So basically, like, very simple, relatively simple thing. So for me, it's like, which AI or which, I don't even know how I'm going to ask it, which model should we use, which technology, how do we connect a backend to an API, to an AI, and then distribute it to users. These are things I would like to learn. And then, any questions so far?
Yeah, what do you want the AI to do, like, in terms of feature?
To be able to, like, real time pull the data. For instance, if I tell the AI, for instance, I would like to, because these things are very dynamic. It changes every time. Sometimes the restaurants, they have deals, right? On Tuesday, maybe they have happy hours, they have different things. How do you do that in a very, like, efficient way? Or if you say, okay, on a Saturday, plan me like a day at this mall, the AI will be able to suggest different things based on maybe there's an event going on this day. See?
See.
Who has the data? Where is the data? These plazas, right?
Okay.
Who inputs data of the plazas?
Okay, you can consider this entire part done.
Okay.
See, you can consider that this part is done. It's more about connecting an AI that's going to sit between the backend.
And you want the AI to make, like, suggestions, let's say.
Exactly.
Based on, like, let's say, whatever restaurant is there. Yeah, kind of like a recommendation system.
Yes, it's a little bit more advanced recommendation system, basically.
So, like, how often does the data change?
Say it again.
How often does the data change?
I would say that's why you have different type of. Sometimes they have calendars, but for an event, that's going to change. Maybe it doesn't. You have the calendar for the entire year, but if you're talking about restaurants, sometimes they can come up with deals, usually around special occasions, and yeah. But some of the because go ahead.
So it doesn't change often then.
It does, because sometimes they run out of stuff, so the inventory is connected to here as well.
Okay. Well, I mean, okay. So, for example, if I take that specific thing, right?
Yeah.
If inventory runs out, I'm thinking that some menus options will not be available then.
Correct.
Right?
Yeah.
So let's say, like, on the data part, like on the left side, if you have an API that serves the inventory, like, every time it's invoked, it can give the actual availability of the different items.
Right.
Then you can, if you want to involve the AI, you can make a call to one of those APIs, and then you can force the AI to inspect that response,
Right.
and then come up with an answer as to like what's available on that. So in a flow like this, if the user says like, "Hey, I want to eat chicken at this restaurant," then when the data is processed that way by the AI in real time, the user can have an answer like, "Hey, actually they are out of chicken, but maybe I see that there's chicken in this other restaurant."
Correct. Yeah.
Yeah.
So, and another thing I would like to mention is most of these businesses, they upload their inventory directly to the backend, for instance, because most of them, they're more focused on special offers. So we can pull the data directly from here, the database.
Yeah. But I'm still trying to picture something, because the case I just described, right?
Right.
Even without AI, it's possible to do it.
Right.
The sentences can be like pre-written. It doesn't need AI for that.
Yeah.
Right.
When you ask, for instance, initially it was a recommendation system, but now people, they have to browse all the time, right? You have to browse. You have to be very specific on. You see here, for instance, when I say like a recommend, because it's basically like almost like a recommendation system. When you have different profile, different people, that type of things, right? You have different profile, you have different people, different things changing all the time. We noticed like a limitation when it was coming with the recommendation system. So that's why I'm trying to see if AI will do a better job.
I mean, for what I'm hearing is, I think you can use the RAG, the advanced RAG approach, since your database is changing, right? So,
Oh, sorry.
well,
okay.
let me think a bit. Yeah. Yeah, the RAG system will not work maybe, because that will have what is it called? Yeah, the RAG system will not work.
We will not.
Will not work, because it has to do with give me a second.
Yeah, plus also, like if all the requests go straight through the AI for processing, that might also be like cost prohibitive.
What do you mean? It's going to be too expensive?
Yeah, it's gonna, especially if it's a busy platform, the price will go up very, very quickly.
Okay. Do we have like some open source AI that we can use?
Yes, even when you use open AIs, open models, like the GPUs are also expensive. Like running GPUs in the cloud is very expensive.
Oh, you're talking more about the server.
Yeah, it's like if you use a third-party API like Claude, or I don't know, OpenAI, or anything else, like they charge you per tokens, right? For a certain number of tokens, they charge you, right? But if it's a high traffic, many requests, like the price will start to ramp up, and okay. So for example, I think, if I'm not mistaken, I think OpenAI, beyond a certain number of requests, you might get like rate limited.
Okay.
Right? And then the way to bypass that would be to have your own installation in the Microsoft cloud, in which case you would also pay for GPUs, since it will be like a dedicated instance.
Okay.
Right. So I'm trying to understand to figure out a scenario where like the addition of AI will pay more dividends.
Right.
Okay. We can self-host an instance, right? Of let's say like an AI, right?
Yes, you can, but the GPUs are expensive. That's what I was trying to say.
Because the AI has to respond still, right? It has to process your request and respond.
Yeah.
Correct. So the cost not going to be like an issue.
Mm-hmm.
The cost not the issue. It's more about being able to navigate. I mean, go through all the offers from these different places and just render in a very simple way for the users.
Right. Which is where.
Okay.
No, I think I was gonna say, which is where maybe the little bit of struggle is coming, because AI. When we talk AI, especially in this scenario, I'm having a hard time seeing, I guess, its value in, because I still feel like it's giving you the information can still be displayed without having to, I guess, use AI, if that makes sense.
Correct. Right. With the once we use like a recommendation system, you have to tell him what to look for.
Okay. So
you have to purposefully write, like, let's say I will say the algorithm, you will say, okay, if the person is like this and it's like, you have to combine the different things, right? Now, when you're talking about different industry, different like verticals, it becomes very complicated to build something like that quickly. One thing I noticed about the AI will be able to go through that and even suggest things that you never thought about. So, especially if you start talking about a large number of items and verticals, different things like that. So that's why I wanted to see if AI can go through that and come up with ways to, I would say again, like being able to recommend in a more accurate way.
Can you guys walk us through a scenario? Maybe combining a few things from like restaurants, events, and maybe a spa, and see like.
Okay, I'll give you a simple example. I live in Las Vegas, right? Usually when people visit Las Vegas, it's for 3-4 days. It's practically impossible to go through everything that the city is offering. If you build a recommendation system for that, it's gonna be extremely complicated to try to build something like that, right? So because of the variety of things that's offered, you have thousands and thousands of offers. So someone who is like 25 will looking for something that's different from someone who's like 50, something like that. Then you add the different what people are looking for. Some people, they want to eat, some people they want to shop. So be able to go through that in a very like efficient way. That's what I thought the AI would be able to do that based on what I heard about AI. I'm not necessarily trying to use the AI. Don't get me wrong. I know I'm using the AI a lot, but what would be the best way to approach that? Maybe I should start by that.
Can I take a shot at it?
Yes, absolutely.
Yeah. So behind the devices, I'm looking at the architecture that you have. Behind that, you can have a program that, based on the user's preferences, builds a template, and that template will be passed to the LLM, and then the LLM will also have access to the backend.
Okay.
To provide a recommendation. Because LLMs, you can pass any chunk of data, right? It can be in CVS format,
okay,
or even JSON. So with the data coming from the backend, the LLM should be able to use the template to provide the answer that you want.
Yeah, absolutely. do you remember last time? I don't remember if it was Kofi, it was Ben. Someone presenting, and you took even like PDF files. I thought it was a book or something like that. Right.
Yeah, we did a hospital. I think it was a hospital example.
Exactly.
Yeah.
Being able to have a variety of data that will be kind of organized in the, I don't know a recommendation system that can do that. Maybe if there's one. If there's, I'll go with that. But I'm trying to see like how I can leverage something, a technology that's going to be a little bit more powerful for that.
Yeah. So maybe I have some other questions then, maybe to help clarify a little bit. So at least from what I've seen, recommendation systems are tailored towards something. It could be like tailored to the user or customer, or it could be tailored to the objective of the company, right? So I know in the past, like I worked for an e-commerce where like they like through their search engine, they had like a feature of their search engine which was basically a recommendation system, right? And the problem that they wanted to solve was that they had so many items for sale that customers had a hard time finding like items that will make the company the most money.
Yeah.
Right. So the recommendation system was made in such a way that it was made in such a way that the items that will benefit the company most, and as well as the customer, will have a tendency to be recommended or bubble up to the top of the results. And then the less important items will basically be hidden. And then in addition to that, they had like before displaying the results, they had quick checks to make sure that items were still available in the inventory and so on and so on. So in the scenario you're describing, like, is it gonna be tailored to the specific user, or is it gonna be tailored to the goal of the company for something like?
It's tailored to the user. It's for the user to be able to sort through, because it's close to what you said. When you have a large number of items, it's very complicated for someone to be able to see, okay, at this moment, what would be the, let's say, if I'm trying to purchase something, there are a lot of variables that you need to take in consideration. The location, like the profile of the user, a lot of things like that. Like I say, it looks like a recommendation system. It's just like a more advanced one. And one thing about, for instance, if you take an e-commerce, you already have all the data organized in a certain way in your database. So it's a little bit easier to build something on top of that. But now when you start talking about bringing different files and be able, some businesses, they have the inventory on a piece of paper, for instance, right? So you want to be able to go through all this data and be able to discover other things. I think that's one of the most important things that we're trying to solve. Be able to know things that we don't know.
Yeah.
Because if I have to build a recommendation system right now, I'll probably go with like the most popular item, reviews, different things, pricing, like kind of predictable things, right? But when I start talking about something more granular, it becomes a little bit complicated to implement.
So basically, is this thing gonna use the user preference at all, or no? Or so let me put this scenario to you. So is it more like, you know how you can go straight to ChatGPT and be like, hey, I'm going to Las Vegas for 3 nights. Can you kind of like create an itinerary of things to do in Las Vegas? And GPT is going to give you the response, right?
Exactly, yes. So
right. Right. So here you can tell GPT, okay, I like to do this, I like to do that, and it'll give you the response based on that, right? But it's using data that's, technically static at this point, right?
Exactly. So,
and
also you have to keep in mind, even if you go on Google, right? Let's say Google. Google is a search engine, but it's more like I would say companies-based search engine. if let's suppose I'm trying to buy pizza right now, Google would tell me, oh, you have different pizza places around you. But if I want a specific pizza, let's say I want pizza with pineapple on. So this is more like a product-based search engine.
Well, I mean, I guess maybe the RAG now comes into place because, are you able to dump all the flyers, the the menus and everything for the whatever model it is to feed onto that, and then have and then from there being able to kind of like question it and tell it, hey, I'm trying to eat this. Can you recommend something? Or I'm at the mall. Can you recommend something?
Correct.
Right.
So, that's why I say consider this part. It's done, right? This part, because that's like data collection, data entry, whatever. Like this is considered this is done. How do you put like a black box right here that can pull the data from whatever is here and display in a very simple way where I have to just click a button. Most people, they know what they want to do. They don't know specifically what they want.
Right. Well, when you say display, are you talking about like displaying just text or displaying actual like things like images or things like that? Like what is it?
So you see here, for instance, you have like a PDF, you have images and you have videos, and you even have external links. Some people make decisions based on what they saw on TikTok or Instagram. I tried a restaurant because I saw them on TikTok or Instagram, something like that, right? So I say, okay, I want something that's, I don't know, something that's very unique. I want a very unique dining experience. I would like this black box to be able to pull it and just show me what makes it unique before you make the commitment. Kind of.
Yeah, from the way I'm looking at it, just that black box I don't think we'll be able to do all that at once. It might be able to do some parts of it, but not. I don't think it will be able to do all of it. I feel like something else needs to be added to it. Some sort of code to also, I guess, bring it all together to display it in one page is what I'm trying to say.
Yeah, absolutely. So, but where do I start if I want to implement this black box?
Yeah, so that's what I was saying. Like, basically, there's a bit of a nuance. Like in the scenario for where I work, like this one basically was automated. There was no real like user input apart from like searching for a product, right?
Okay.
Because before something makes it into the search engine, like there was some training done. It wasn't at the AI level with LLMs like we see today. It was basically regular machine learning, right?
Okay.
So based on the description of the product, based on price, based on a number of like constraints, some weights are derived and added to each one of the products, and then those weights will determine how the products are listed in the search response, right? So the ones with higher weights will bubble to the top. The ones with smaller weights will go further down, right? But then there's the scenario, like if we're talking LLM, the LLM still has to be prompted. The user has to take actions to say, yeah, I want X, Y, Z constraints to be met.
Absolutely.
Then the LLM will figure out how to narrow it down, like through different libraries, like the one I showed today, like Instructor, for example, and do some function calling and whatnot, and try to like narrow it down. So in that case, it's not really like a recommendation engine per se. it's something that's like done on the fly.
Correct. Yeah.
You know, I mean, the recommendation engine will be like if you get to click on a product, like on Amazon, right? You click on the product, and then all around it there are other products that are recommended.
Yeah.
You know, this is done like ahead of time.
Exactly.
But if it's a textual like interaction, then it's more like on the LLM part, and then this is done in real time. You know.
Yeah, I think you presented like exactly how I want it to be.
Yeah. So if it's the real, yeah, go ahead.
I was going to ask: is this set up in the cloud somewhere, or you have it locally?
Which one? You're talking about the backend, or you're talking about the
backend?
Yes, everything is set up in the cloud. You know, that can be an API can be exposed. So the black box, I call it black box one. The black box will just pull the data from there and do, because it's like through the presentations that you guys were doing, especially the day we talked about RAG and stuff. I saw how it's very specialized, right? Even when we were talking about the medical industry, you take your existing data and then you can kind of train the black box. So the black box will make better recommendation or suggestions, or you will discover things that you didn't even know were there. So it's a little bit that I'm trying to achieve right here.
Yeah, but the right scenario, go ahead.
Yeah, I think that setup will work. You know, you can start with that initially to see how the results looks like before you go towards training the model, right? Because your data, even though it doesn't change that much, it still changes. So once you train it one time, you have to have a pipeline where, you know, maybe every 6 months you have to retrain the model.
Okay, I'm taking some notes. Right? So for something like that, what would be like the next step?
For initially, I'll lean towards OpenAI to get a setup done. As I think Ben said, you may run into cost issues. So once you have the setup done, you can substitute any model with OpenAI.
Okay. Okay. So yeah. So what I'm going to do, I'll probably like write some like more in depth kind of requirements and just try to call each of you guys and see.
Yeah, it's like if you have an actual scenario, it's easier to figure out.
There's an actual. This is an overview. This is something I did pretty quickly, and I wanted to see if that was something that's first of all doable. To see, for instance, even like the way I'm approaching the whole thing was kind of right, and then I can kind of share more details about like the real case.
Yeah. Yeah.
Okay.
So it's doable, but to refine it, it just depends on the specific scenario.
Okay.
Yeah. You'll have to build a lot of good templates to cover all the different shops and events in the malls. So
okay,
it will not be like just one template. You'll have several templates doing prompting different things, scenarios.
Yeah. So, like for me, like I would say my generic recommendation would be that if it's something that that doesn't really depend on the user, then doing it the regular way with machine learning techniques to get paired with like a search engine or something, that can get the job done, right? But if it's something where, that's very custom for the user, and it has to be done real time, and especially if it's something that's like very, very tedious for the user, then the LLM part will be the way to go. But even on that part, it's not automatic. There's actually a lot of work involved to make it do the complicated task. So.
No, definitely.
Yeah.
Okay. So I think I have a pretty good sense of what I need to prepare. Then I'll be able to kind of implement that.
Anyone else has any ideas or suggestions?
Not at the moment.
Okay. Yeah. Okay. Thank you. I don't want to kind of use too much of your time. So.
Yeah, maybe like there's one last thing I just thought about. Maybe like, I don't know if it's gonna present itself as a website or something, but maybe if it's like a website, for example, maybe there could be like something like an agent that can follow the user around and assist the user like perform different things. Like, I don't know, the user is looking at the menu of a restaurant and then wonders if it's halal, for example.
Correct. Yes.
And the user can just talk to it and find out. Yeah.
Yeah. Exactly. Yeah. You did it.
Like
There.
Right. Yeah, but does that agent go from website to website, or
no,
do they
on one website? You see, everything is organized there. So sometimes I want to know more about this specific item. Let's suppose, for instance, I say I want to eat, and then recommend something. I say, okay, show me the menu. Shows me the menu, but I want to know more about this specific dish that they're offering. You see that it becomes more and more granular.
Yeah.
If this data is already inside the I would say the database, the website, so it's just like a nice way to organize it, so the user can kind of interact. It's almost like I'm interacting with this platform.
Yeah.
I can know more about the item before I'll purchase it, or maybe before I'll kind of RSVP for the restaurant.
Right. Yeah.
So what I'm going to do also, I will probably send you later on like the way the offers and everything is organized on the site, and you can see the endpoint, the API, and you can maybe that's going to give you like a better sense of how data are organized there. Okay.
Yep.
Okay. Yeah, that was it on my end.
Thank you for sharing. That's why we have this.
Like an interesting project, it looks like.
Yeah.
Yeah, thank you for taking the time to listen, and thanks for the feedback as well.
Yeah, no problem.
All right. Talk later.
Okay. Thanks, everyone.
Bye.
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 Right.
Yeah. Okay.
Moi, je sais que vous vous laissez jusqu'à la fin pour débriefer.
Well, you said that il y a so many